Welcome to Mitchell Maths. In this video we're going to have a look at congruent triangles. What we mean by congruent triangles is where triangles are exactly the same, which means that all lengths and all angles in both triangles will be identical. And when we're trying to prove that two triangles are congruent, there's a few ways in which we can do this. We can prove that all three sides are equal, which is called side, side, side. We can prove that two angles and a corresponding side are equal, angle, angle, side. We can also prove that we have something called side, angle, side, which means two sides and the angle in between them. And we've also got one for right-angled triangles, which is sort of the right angle, hypotenuse and side. You need to prove that they're both right-angled, you need to prove the hypotenuse is the same length, and then you have to prove that one of the other sides is the same. So that works for right-angled triangles. And as long as you can prove one of these statements, then you've proved that both triangles are the same. So let's have a look at the first question. It's given us an isosceles triangle, and that tells us that AB is the same as AC, because the two triangles we're trying to prove are congruent are the same, is ABD, which is on the left-hand side, and ACD, which is on the right-hand side. And we know that AB and AC are equal, because it's isosceles. And yeah, you don't need to write an essay, but you do need to write how you know that each of the sides are equal. So AB equals AC, isosceles triangle. We've also got AD, which is in both triangles. So AD is equal to AD, because it's the same side or length. And the last side we're going to get, we're going to do side, side, side here, is we know that D is the midpoint of BC. And if D is the midpoint, that means BD must be the same as DC, because D's exactly in the middle. So we get BD equals DC. Because D is the midpoint of BC. And what that tells us is that we've got side, side, side. So we've proved that those two triangles are congruent. Right, in the next question, so this is a rhombus, and we can do it's very similar if it's a parallelogram as well. There's two ways which we can do this. I'm going to choose a different rule just as an example. We know that opposite angles in a rhombus are equal. So first of all, I'm going to prove that angle A is the same as angle D. So we put angle BAC is equal to BDC, because opposite angles in a rhombus. So we know that those two are equal. Now we need to prove that some of the sides are equal. Well, we know that AB equals DC. And we know that DB is equal to AC. Because all sides in a rhombus are equal, if this would be a parallelogram, we would just say the opposite sides are equal. But we can say all sides equal in rhombus. So what we've done here is we've proved that that's equal to that, and that this is equal to this, which means we've got side, angle, side, because we've got two sides and the angle in between them. So our proof is side, angle, side. We've proved that those two triangles are congruent, the same. You could also do side, 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 because you could say that BC is equal to BC, and because you know that length in the middle is the same length in both triangles. And the last one we're going to have a look at is this one. So you might have seen this sort of shape before from circle geometry. And what you know is that when a tangent meets a radius, that you get a 90-degree angle, because what they've told you is that O is the centre of the circle, so OB and OC are radiuses, and it also tells you that AB and AC are tangents. So with those two pieces of information, you know that this angle here and this angle here are both right angles. So OBA and OCA both right angles, and I'll just put radius meets tangent, because that's one of your circle theorem rules which you need to know. Right, so I've got a right angle. I also need to next prove that the hypotenuse is equal. So what's the hypotenuse? Well, that's OA, and actually that's the same length for both of them. So OA equals OA. It's the same length, so it's going to be the same for both. And then we need to prove that one of the other sides is equal. Well, we can see that they both contain a radius, OB and OC. And it doesn't matter where the radius is in a circle, it's always going to, the radius is the radius, so it stays the same. So both radius of circle. So what we've done is we've proved that it has a right angle, that the hypotenuse is equal because that's the same length, and one of the sides is equal because they're both OB and OC are both the radius of the circle. Therefore, we've got RHS. Right, thank you for watching. I hope you found that helpful. If you'd like to see more videos, please hit the subscribe button. And for practice questions, please visit my website, www.mitchellmathsandscience.com. The link is in the description.